Do you know how small the smallest electronic components in the world are? In high-precision products like smartphones, you can't see them at all without a microscope. So here's the question. How are these extremely tiny and numerous components accurately and efficiently soldered onto PCBs in mass production? First, the PCB is fed into the machine for the solder paste printing process. A prefabricated stencil is placed in the center of the machine. The holes in the stencil correspond to the pads where solder paste needs to be applied. Top and bottom lights illuminate toward the scented, and the machine adjusts the PCB's position based on the light data. This ensures the PCB aligns precisely with the stencil openings. Once aligned, a squeegee moves forward, pressing lead-free solder paste through the stencil onto each pad on the PCB. A laser sensor at the front of the machine measures the thickness and diameter of the solder paste. If insufficient paste is detected, the upper solder paste cartridge automatically replenishes it through this device. Once finished, the board moves on to the next step: pick and place. Operators first prepare component reels in advance, placing them into the corresponding feeders based on size and type. Let's focus on those components smaller than a strand of hair, which are fed through a specific entrance. These components are barely visible to the naked eye, but the machine's recognition system is highly advanced. These tiny parts scatter onto this transparent tray. A red light is projected from below, allowing the machine to detect the exact position of each part. Different modes can be set to instruct the machine which components to pick. Once positioned, the machine begins rapid picking. Look at the speed, it's unbelievably fast. In slow motion, every pick is incredibly stable. This pick and place machine not only picks quickly and steadily, but also automatically scans each part after picking. This ensures no component is picked incorrectly. It also recognizes the placement area and automatically adjusts the angle for precise placement. It controls the placement force very precisely. It automatically adjusts speed depending on the component, then gently and precisely places it down. Finally, it applies accurate pressure. Even veteran soldering technicians with decades of experience would be impressed. Even if the PCB has slight warping, the force control remains spot on. Thanks to this high-speed placement machine, no matter how small or how many components, the whole board is completed in the time it takes to play one song. Next is the high-temperature soldering process. In the reflow oven tunnel, the temperature gradually increases toward the back. At this stage, both the leads and the BGA solder balls underneath the chips are melted in an orderly fashion. The process includes preheating, peak temperature, and then controlled cooling for through-hole components. Another method, wave soldering, is used. It works by spraying molten solder from below like a fountain. The solder wave just touches the pins. At its peak, an incredibly satisfying process, with preheating, soldering, and cooling all in one process. No matter how many or how small the pins, its efficiency surpasses 100 soldering technicians. There's also another type of wave soldering, where the board is preheated and then slowly passes over a wide stream of molten solder. Note that one stream flows left, the other right, ensuring complete coverage of every solder point. From this angle, you can see the contact area is very broad. The entire process focuses on complete coverage. By the end of the process, the PCB is fully soldered and successfully completed.